And now in this lecture we will find out the value of x. In the drawing we have a quarter circle, AFE is a quarter circle. Inside this quarter circle we have this square ABCD. In addition we know that line segment DE, this is line segment DE, that is equals to 12 units in Islam. This is angle GDC, that is equals to theta. This is angle EDC, that is also equals to theta. And our mission is to find out the length of this line segment DG, that is equal to x. So we have to find out the value of x. Okay, so first of all, we know that all the angles inside square ABCD are right angles, so those four angles, they're all right angles. So this angle equals to 90 degrees in its size. This is also a right angle. This is a right angle. Finally, this angle is also equals to 90 degrees in its size. In addition, we know that the opposite sides of a square are parallel to each other. Again, the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to side AB. So DC is parallel to side AB in square ABCD. But AB is part of the straight line AE. Again, AB is part of the straight line AE. And we know that if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, the straight line AE itself must be also parallel to DC. So AE must be also parallel to DC. So the straight line AE is parallel to DC. Here we can implement rule 15. I repeat quickly rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have line A, this is line A, that is parallel to line B. In addition, we have those two angles, alpha and beta. Angles alpha and beta are defined as alternating angles and they are located between the parallel lines A and B. That is to say, line A is parallel to line B and therefore they are equal to each other. That is to say, alpha equals to beta. So whenever you have two alternating angles that are located between parallel lines, they must be equal to each other. So we can implement rule 15 in our drawing, because in our drawing we have line AE is parallel to line DC. Of those two angles, they are defined as alternating angles and they are located between the parallel lines AE and DC, and therefore they must be equal to each other. So this is angle EDC. Angle EDC and it is equals to this angle, that is actually angle AED. Angle AED, and they are equal to each other according to rule 15. Because of the fact that those two alternating angles are located between the parallel lines AE and DC, they must be equal to each other. So that is, they must be equal to each other. That is to say, angle EDC is equal to this angle, angle AED. But this angle equals to theta according to what is given in the question. So we can write here that angle EDC equals to theta. And from this equation, theta equals to angle EDC equals to angle AED. We derive that angle AED is also equals to theta. Angle AED equals to theta. So this is angle AED, that it must be equal to theta also. In the next step, we will do a construction That is to say, from point G we draw perpendicular on AB. Again, from point G we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point between the perpendicular GN and side DC of this square as M. By doing this construction, we created quadrilateral DMAN. This is quadrilateral DMAN. Inside this quadrilateral DMAN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this missing fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Why? Because 90 degrees plus the sum of those 4 angles, that is 270 degrees, in total it is 360 degrees, that is the sum of the angles in any quadrilateral. So inside this quadrilateral DMAN we have 4 right angles, and we know that any quadrilateral that has 4 right angles must be at least a rectangle if not a square, so we relate to this quadrilateral DMAN as a rectangle, because it has 4 right angles. So GN is perpendicular on AB. GN is perpendicular, it is absolutely a straight line. So if you focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees, according to rule 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is the right angle plus the missing angle. In total, the sum of those 2 angles must be equal to 180 degrees, according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, triangle GMD is a right angle. So I will copy this right angle, triangle GMD, in a new page, and we will analyze this right angle, triangle GMD. So actually, this is the right angle GMD that I copied from the original drawing. In this right angle GMD, it is very easy to see that cosine theta equals to dm over gd. So cosine theta equals to dm is the missing side, so we leave it as it is, over gd. Gd equals to x according to what is given in the equation, so we'll substitute gd by x. So actually found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x. And finally we get that according to equation 1, dm equals to x times cosine theta. In the next step, I will copy this right triangle ADE in a new page. We will analyze this right triangle ADE, but before that we will define one side of this square ABCD as y, and therefore all the four sides of this square ABCD must be equal to y, of course. So AD equals to y, AB also equals to y, BC equals to y, and finally side DC also equals to y, according to our definition. Now I'll copy this right triangle ADE in a new page. We will analyze this right triangle ADE. The hypotenuse D equals to 12 units in its length, according to what is given as the question. AD equals to y according to our definition. And finally, what is the length of side AE? Side 97 AE starts from point A, that is the center of the quarter circle, and ends at point E, that is the point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We will define the radius of this quarter circle as r. Therefore, A equals to r. So actually, this is the right triangle ADE that I got from the original drawing. In this right triangle ADE, cosine theta this will be equation 2, cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. So according to equation 2, we actually found out that cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. We have here two equations. Actually here we can substitute cosine theta in this equation 1, by r over 12 from this equation 2. We'll do it now, and we'll get that dm is equals to x times cosine theta. Cosine theta is r over 12 according to equation 2. So in total we actually found out that dm equals to xr over 12. dm equals to xr over 12. So actually this is side dm, and it is equals to xr over 12. xr over 12. We've already found out that quadrilateral DMAN is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. So a rectangle DMAN, side DM must be equal to the opposite side AN. But DM is XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule, in the same rectangle DMAN, side DA must be equal to the opposite side MN. DA must be equal to the opposite side MN. But DA is Y, therefore MN must be also equal to Y. In the next step, I'll copy again this right small triangle DGM in the new page, and we'll continue to analyze this right triangle DGM. So actually, this is the right triangle DGM that I got from the original drawing. This right triangle DGM is very easy to see that sine of theta equals to GM over GD. Again, sine of theta equals to GM over GD. So, sine of theta equals to GM. GM is the missing side, so we leave it as it is. Over GD. GD is X, therefore we substitute GD by X. So, in total, we found out that sine of theta equals to GM over X. So here we multiply this equation 1 by X, and finally we get that according to equation 1, GM equals to X times sinus theta. Okay, this is according to equation 1. So in the next step, I will copy again the right triangle ADE in this new page, and we will continue to analyze the right triangle ADE. This is the right triangle ADE. So this is the right triangle ADE that I copied from the original drawing. This is again theta, of course. So in the right triangle ADE, it is very easy to see that sinus theta equals to dA over dE. Again, sinus theta equals to dA over dE. So sinus theta equals to dA, that is y, over dE, that is 12. So in conclusion, we found out that according to equation 2, sinus theta equals to y over 12. This is according to equation 2. While according to equation 1, we have already found out that Gm equals to x times sinus theta. So we have here two equations. Now we can substitute sinus theta in this equation 1 by y over 12 from this equation 2. We'll do it now, and we'll get that according to equation 1, Gm equals to x times sinus theta. And sinus theta is y over 12. y over 12. So in conclusion, we should find out that gm equals to xy over 12. gm, so this is side gm, that is equals to xy over 12. In the next step, we will join points A and G together by a straight line. So, what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equals to R according to our definition. In the next step, I will copy this right triangle AGN in a new page, and we will implement on this right triangle AGN the Pythagoras theorem. Here by PT is abbreviation for Pythagoras theorem. The hypotenuse AG equals to R. Is also the radius of the quarter circle. AN equals to XR over 12. This is side AN. And what is the length of side GN? From the moment it is very easy to see that side GN in total equals to GM plus MN. That is to say, GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. So this is right triangle AGN as I go from the original domain. We just right now found out that side GN equals to XY over 12 plus Y, AN equals to XR over 12, and finally the hypotenuse AG equals to R. So here by PT is the abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle AGN, it means that AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square. XR over 12 square equals to X square times R square over 12 square, that is 144. So in total, XR over 12 square equals to X square times R square over 124 plus GN square. GN equals to XY over 12 plus Y, therefore GN square equals to XY over 12 plus Y square. So according to equation 1, R square equals to X square times R square over 144, and we have here XY over 12 plus Y square. So here we take Y as a common factor from this expression. So what is left from xy over 12 after we took from it y as a common factor? What is left is it is actually x over 12 plus y. What is left from y after we took from it y as a common factor? What is left is actually 1 all squared. So here we'll use the algebraic identity that states that a times b to the power of m equals to a to the power of m times b to the power of m. Again, a times b to the power of m equals to a to the power of m times b to the power of m. So according to this algebraic identity, we get that y times x over 12 plus 1 square will be equal to y square times x over 12 plus 1 square. And I'll copy this to expression here. It is plus x squared times r squared over 144, and it is equals to r squared according to this equation, equation 1. So here we will multiply 1 by 12 and then we divide it by 12 in order to overcome factor with x over 12, and we get that according to equation 1, r squared equals to x squared times r squared over 144 plus y squared. Again, here we multiply 1 by 12 and then we divide it by 12. So in total, the numerator of this expression will have x plus 12 divided by 12 squared. Let's do it again. So after we multiply 1 by 12 and then we divide it by 12, we will have here x plus 12 over 12 squared. And we multiply it by y squared, and it is plus x squared times r squared over 144, that is equals to r squared according to this equation, equation 1. So here we use the following trigonometric identity. That a over b to the power of m equals to a to the power of m over b to the power of m. So according to this algebraic identity, this is an algebraic identity, of course. According to this algebraic identity, x plus 12 over 12 square will be equal to x plus 12 square over 12 square, and 12 square is 144. So in total, x plus 12 over 12 square, according to this algebraic identity, will be equal to x plus 12 square over 12 square, that is 144. And we have to multiply it by y square plus x square times r square over 144, and it is equal to r square according to this equation, equation 1. So in the next step, we'll join points A and C together by a straight line. We join those 2 points by a straight line. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and then at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R according to our definition. So by doing this construction, by joining points A and C together by straight line, we created the right triangle, triangle ABC. So we copy this right triangle, triangle ABC in a new page, and we will implement on this right triangle ABC the Pythagoras theorem. Side AB and side BC of this right triangle, triangle ABC, they are both equal to y, because they are both the sides of square ABCD, and we know that all the sides of this square ABCD are equal to y according to our definition. Again, here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle, triangle ABC that I copied from the original drawing. This right triangle, triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. Repeat again, the right triangle ABC, AC square equals to AB square plus BC square. According to the Pythagoras theorem, AC is R, therefore AC square is R square. And it is equal to AB square. AB is y, therefore AB square is y square plus BC square. BC is also y, therefore BC square is y square. So we found out that according to equation 2, R square equals to y square plus 2y square is 2y square. So according to equation 2, R square equals to 2y square. This is according to equation 2, while according to equation 1, we have already found out that R square equals to x square times R square over 144 plus y square times x plus 12 square over 144. So we have here two equations for R square. So in the next step, we substitute R square in this equation, equation 1, by 2y square from this equation, equation 2. We will do it now, and we get that according to equation 1, R square is 2y square, and it is equals to x square times R square. R square is 2y square over 144 plus y square times x plus 12 square over 144. So here we will divide this equation 1 by y square, and we get that according to equation 1, 2y square over y square is 2, and it is equals to, here y square will get cancelled, and we left only with 2x square over 144 plus, here y square also will get cancelled, and we left only with x plus 12 square over 144. So here we multiply this equation, equation 1 by 144, get that according to this equation, equation 1, two times 144 is 288, and here 144 will get cancelled, and we'll have to live with 2x squared, plus here 144 also will get cancelled, and we'll have to live with x plus 12 squared. So according to equation 1, we found out actually that 288 equals to 2x squared plus x plus 12 squared. So here we'll open the brackets of this expression. This is this equation, equation 1. And we get that according to this equation, equation 1, 288 equals to 2x squared plus x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So we found out that according to this equation, equation 1, 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. So here we subtract 288 from this equation, equation 1, and we get that so 288 times 288 is 0, and it is equals to 3x squared plus 24x. 144 plus 288 is minus 144. So here we divide this equation, equation 1 by 3, and we get that according to equation 1, 0 over 3 is 0, and it is equals to 3x squared over 3 is x squared, plus 24x over 3 is 8x, minus 144 over 3 is minus 48, so actually, according to equation 1, we found out that x squared plus 8x minus 48 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a is equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we put those values of a, b, and c for our specific quadratic equation in this general formula for x in order to find out the value of x in our specific quadratic equation. We do it now, and we get that x equals to minus b. B is 8, therefore minus b is minus 8, plus minus the square root of b squared. B is 8, therefore b squared is 8 squared, that is 64, minus 4 times a. A is 1, therefore minus 4 times 8 is minus 4 times 1, that is minus 4 times c. C is minus 48, therefore minus 4 times minus 48 equals to plus 192. So in total, inside the root we have 64 plus 192 over 2a. A is 1, therefore 2a is 2 times 1, that is 2. So actually found out that x equals to minus 8 plus minus. Inside the root we have 64 plus 192. 64 plus 192 is 256 over 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x equals to minus 12, but x can never be equal to minus 12 because of the fact that x is the length of this line segment GD, and x as a length must be a positive number. So the negative solution is the incorrect solution. We cancel this solution, and we will take into account only the positive solution for x. And the positive solution for x is as follows. X actually, according to the second solution, the second positive solution, is equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So we actually found out that this is line 7GD. So line 7GD that is equal to x, according to what is given as the question, is equal to 4 units. And that is the answer to the question. So in the next step I will summarize the lecture. In this lecture, we found out the length of this line segment, line 7GD, is equal to x according to what is given as the question. So we found out the value of x. So in the domain we have a quarter circle. AEF is a quarter circle. Inside this quarter circle we have this square ABCD. In addition, we know that this is line segment DE that is equals to 12 units in its length. This is angle GDC that is equal to theta. This is angle EDC that is also equal to theta. And our mission is to find out the length of this line segment GD that is equal to x. We have to find out the value of x. Okay, so first of all, we know that all the angles inside n square are right angles. So, and especially it is true in square ABCD. So in this square ABCD, those 4 angles are all right angles. In addition, we know that the opposite sides of a square are parallel to each other. Again, the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to the opposite side AB. DC is parallel to AB. But AB, side AB is part of the straight line AE. Again, side AB is part of the straight line AE. And we know that if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. And therefore the straight line itself, AE, must be also parallel to DC. Okay, AE must be also parallel to DC. Here we can implement rule 15. Repeat quickly on rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. So we have in the drawing line A. This is line A that is parallel to line B. In addition, we have those two angles that are defined as alternating angles, and they are located between the parallel lines A and B. That is to say, line A is parallel to line B. And therefore, they are equal to each other. Whenever we have two alternating angles that are located between parallel lines, they are equal to each other. And therefore, angle alpha equals to angle beta because of the fact that they are located between the parallel lines A and B. We can implement rule 15 in our drawing. In our drawing, we have DC, line DC is parallel to line AE, and those two angles are defined as alternating angles, and they are located between the parallel lines DC and AB, and therefore they are equal to each other. That is to say, those two angles are equal to each other according to rule 15. Angle EDC equals to angle AED according to rule 15. But this is angle EDC that's equal to theta. So we can write here that angle EDC equals to theta according to what is given as the equation. And from this equation, theta equals to angle EDC equals to angle AED. We derive that angle AED is also equals to theta. This is angle AED that is also equals to theta. So in the next step, we did the construction. That is to say, from point G, we draw perpendicular on AB. Again, from point G, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point of the perpendicular GN with side DC as M. So by doing this construction, we get a quadrilateral DMNA. This is quadrilateral DMNA. In this quadrilateral DMNA, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. In order to complete the sum of the angles inside this quadrilateral to 360 degrees, the missing fourth angle must be equal to 90 degrees in its size. So inside quadrilateral DMNA we have 4 angles, and we know that any quadrilateral that has 4 angles must be this rectangle if not a square. So we relate to this quadrilateral DMNA that has 4 angles as a rectangle. Okay, so GN is perpendicular on AB. So GN is a perpendicular, it is absolutely a straight line. So if you focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to rule 3 that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, the small triangle GDM is a right angle. So I call this small right angle GDM in the new page and analyze this small right angle GDM. Actually, this is right angle GDM, the document from the original drawing. This right angle GDM or GMD. It is very easy to see that cosine theta equals to dm over GD. Again, cosine theta equals to dm over GD. dm is the missing side, so we leave this it is, over gd. gd is x, so we substitute gd by x. So in total, actually, we found out that cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. This is according to equation 1. In the next step, we define one side of this square ABCD as y, and therefore all the four sides of this square ABCD must be also equal to y, of course. AD equals to y, DC equals to y, CB equals to y, and AB equals to y, according to our definition. And what is the definition of side AE? Side AE starts from point A, that is the center of the quarter circle, and then at point E, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We define the radius of this quarter circle as R, and therefore AE equals to R. So this is the right angle ADE that according from the original domain. It is given us a question that DE equals to 12 units in its length. So this right angle ADE, it is very easy to see. This is actually, of course, angle theta. In this right angle ADE, it is very easy to see that cosine theta equals to AE over DE. Again, cosine theta equals to AE over DE. AE is R, DE is 12, so in total cosine theta equals to R over 12. This is according to equation 2, cosine theta equals to R over 12. Well, according to equation 1, we have already found out that dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1 by R over 12 from this equation 2. We did it, and we actually found out that dm equals to x times cosine theta. And cosine theta is R over 12, and therefore dm in total equals to xr over 12. So this is side dm, this equals to xr over 12. We already found out that quadrangle DMNA is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side DM must be equal to the opposite side AN, but DM is XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the symbol, in the sum of rectangle DMNA, side DA must be equal to the opposite side MN, but DA is Y, according to our definition, therefore MN must be also equal to Y. In the next step, I copied the small right triangle GDM in the new page, and we continue to analyze this small right triangle GDM. So this is the small right triangle GDM that I copied from the original domain. In this small right triangle, it is already to see that sinus theta equals to GM over GD. Again, sinus theta equals to GM over GD. GM is the missing side, so we leave it as it is over GD. GD is x, so we substitute GD by x. So in total, we can find out that sinus theta according to equation 1 equals to GM over x. Here we multiply this equation 1 by x, and finally found out that GM equals to x times sinus theta. This is according to equation 1. In the next step, I copied again this this right triangle ADE in the new page, and we continue to analyze this right triangle ADE. This is the right triangle ADE that according to the original domain. In this right triangle ADE, it is very easy to see that sinus theta equals to dA over dE. Again, sinus theta equals to dA over dE. dA is y, dE is 12. Therefore, in total, sinus theta equals to y over 12. This is according to equation 1. While according to equation 2, we have already found out that dm equals to x times sinus theta. So we have here two equations. So here we can substitute sinus theta in this equation 1 by y over 12 for this equation 2. We did it and found out actually that gm equals to x times sinus theta, and sinus theta is y over 12, and therefore gm in total equals to xy over 12. Again, gm in total equals to xy over 12. So this is gm equals to xy over 12. In the next step, I join points A and G together by straight line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and then at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equal to R according to our definition. In the next step, I copy this right triangle AGN in the new page, we implemented the Pythagoras theorem in this right triangle, triangle AGN. This is right triangle AGN, the form from the original domain. We just right now found out that the hypotenuse AG equals to R. We already found out that AN equals to XR over 12. Here, AN equals to XR over 12. And what is the length of GN? What is the length of side GN? From the law, it is very easy to see that GN in total equals to GM plus MN. So GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. And again, GN in total equals to XY over 12 plus Y. So according to the Pythagoras theorem, in this right triangle AGN, AG square equals to AN square plus GN square. Again, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square. XR over 12 square equals to X square times R square over 12 square, that is 144. So in total, XR over 12 square equals to X square times R square over 144 plus GN square. GN equals to XY over 12 plus Y, therefore GN square equals to XY over 12 plus Y square. So according to question 1, we shall find out that R square equals to X square times R square over 144. So here we took Y as a second factor for this expression. So Y is a second factor. So what is left from XY over 12 after we took from it Y as a second factor? What is left is actually X over 12. And here we have what is left from Y after we took from it Y as a second factor. What is left? It's actually 1 and all squared. So according to equation 1, we shall find out that R square equals to X square times R square over 144. And here we have this expression. Actually, we use the algebraic identity that states that A times B to the power of M equals to A to the power of M times B to the power of M. According to this algebraic identity, we get that Y times X plus 12 plus 1 square equals to Y square times X plus 12 over 1 square. Okay, and then we multiplied 1 by 12 and then we divided by 12 in order to overcome factor with X over 12. So after we multiplied 1 by 12, in total the numerator will have X over 12 divided by 12 square. Okay, so this expression will be equal to X plus 12 square, or X plus 12 over 12 square. And we have to multiply it by 1 square plus X square times R square over 144, that is equal to R square according to equation 1. So here we have the algebraic identity. So according to equation 1, R square equals to X square times R square over 144 plus Y square, and we have used here the algebraic identity for this expression. Actually, X plus 12 over 12 square equals to X plus 12 square over 12 square, that is 144, according to this algebraic identity, that A over B to the power of M equals to A to the power of M over B to the power of M. Again, according to this algebraic identity, X plus 12 over 12 square equals to X plus 12 square over 12 square, that is 144. So finally, according to equation 1, we shall find out that R square equals to X square times R square over 144 plus Y square times X plus 12 square over 144. In the next step, we join points A and C together by straight line. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and then at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R, according to our definition. By joining points A and C together by straight line, we created the right triangle, triangle ABC. So according to this right triangle, triangle ABC, in the Olympiad, we implemented the Pythagoras theorem on this right triangle, triangle ABC. This is the right triangle ABC that I copied from the original domain. We just right now found out that the hypotenuse AC equals to R. It is also the radius of the quarter circle. Side AB and side BC, they are both equal to Y because of the fact that the sides of square ABCD, and you know that all the sides of square ABCD equals to Y according to our definition. So in this right angle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC is y, AC is r, therefore AC squared is r squared, and it is equals to AB squared. AB is y, therefore AB squared is y squared plus BC squared. BC is also y, therefore BC squared is y squared. So in total, we should find out that according to equation 2, r squared equals to y squared plus y squared, that is 2y squared. So according to equation 2, r squared equals to 2y squared. So we have here two equations. According to equation 1, r squared equals to 2y squared. Well, this is according to equation 2. According to equation 2, r squared equals to 2y squared. Well, according to equation 1, we already found out that r squared equals to x squared times r squared over 144 plus y squared times x plus 2f squared over 144. So we have r squared on both equations. And therefore we can substitute r squared in this equation 1 by 2y squared for this equation 2. We did it and found out that r squared, according to r squared, this is r squared, so r squared according to equation 2 is 2y squared, and it is equals to x squared times r squared, and r squared is 2y squared over 144 plus y squared times x plus 12 squared over 144. Here we divided this equation 1 by y squared, and found out actually that according to equation 1, 2y squared over y squared is 2, and it is equals to, here y squared will get cancelled, and we have to only with 2x squared over 144. Here y squared also will get cancelled, and we have to only with x plus 12 squared over 144. Here we multiply this equation 1 by 144, and finally found out that according to equation 1, 2 times 144 is 288. And here 144 will get cancelled, and we left only with 2x squared. Here 144 also will get cancelled, and we left only with x plus 12 squared. So according to equation 1, 288 equals to 2x squared plus x plus 12 squared. Here we open the brackets of this expression, and finally found out that according to equation 1, 288 equals to 2x squared plus x plus 12 squared. X plus 12 squared equals to x squared plus 12 squared, that is 144, over 2 times x times 12, that is 24x. So according to equation 1, we can find out that 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we subtract 288 from this equation 1, we find out that 288 plus 288 is 0, and it is equals to 3x squared plus 24x, and 144 minus 288 equals to minus 144. So here we divided this quadratic equation 1 by 3, and finally found out that 0 over 3 is 0, and 3x squared over 3 is x squared, and 24x over 3 is 8x, and minus 144 over 3 is minus 48. So we have here the equation 1, according to equation 1, x squared plus 8x minus 48 equals to 0. So this is a quadratic equation. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. We find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So we have to put the values, those values of a, b, and c that we found for our specific quadratic equation in this general formula for x, in order to find out the value of the values of x for our specific quadratic equation. We did it, and we actually found out that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a is 1, so minus 4 times 1 is minus 4, times c is minus 48, so, and minus 4 times minus 48 is plus 192, divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So we found out that the x equals to minus 8 plus minus, and we have 64 plus 192 is 256, so inside the root we left only 256 divided by 2. So x equals to minus 8 plus minus, the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So actually found out that According to the first solution for x equals to minus 12 units, minus 12. But x can never be equal to minus 12 because of the fact that x is the length of this line segment GD, and x as a length must be a positive number. So we cancel the negative solution for x, and we take into account only the positive solution for x, and the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So we shall find out that the length of this segment GD is equal to x is equal to 4 units. Okay, thank you very much.